one of the best ways to learn how to code is to challenge yourself with difficult projects. And some of the most fun projects you can challenge yourself with are games. If you're learning Java, you've probably done the FizzBuzz game, and you've probably done the number guesser game. And if you've moved up in your Java skills, you've probably done rock, paper, scissors. But one of the more difficult games that you can code is the tic-tac-toe game. And that's what I want to show you how to code right now. Now, if you're learning Java, I urge you to try and code the tic-tac-toe game on your own first. Just think about it, challenge yourself, and see how far you get along. And then if you get stuck, or you want to see what my approach is, we'll take a look at the rest of this video. Hi, I'm Cameron McKenzie. I'm the editor-in-chief over at TheServerSide.com, and I have to be one of the world's biggest Java advocates. And when I started to learn how to program in Java, I started with the tic-tac-toe game, and that's why I want to step you through the tic-tac-toe game as well. Before we start coding, we should probably talk about maybe the design of the tic-tac-toe game, or for that matter, just talk about how tic-tac-toe works. When the game starts off, we're just going to display the tic-tac-toe board to the user. There's 9 positions in the board, and we're just going to number them from the top left-hand corner to the bottom right-hand corner. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're actually just going to store that information, store those numbers in an array of chars that we'll have in the application. We'll then ask the user to select one of the numbers representing an available slot on the board. When they choose the number on the board that's available, we'll update our array of chars accordingly, and then check to see if that player has won the game. Each player is going to be associated either with X's or O's, and so once the player O has played their game, and if they haven't won, we'll switch to X. Similarly, if X plays the game and they haven't won, we'll switch to O. We'll keep playing the game over and over and over again until it's been played 9 times. If it's been played 9 times and there's no winner, well, we will declare it a tie. And if during the game somebody wins, well, we will congratulate them, declare them the winner, and then we will end the game. But the first thing that we're going to need to do is declare that array of chars representing each spot on the board and print out that board, which is exactly what we're going to do next. So if we're going to code this tic-tac-toe game in Java, I guess we do need a Java class called Tic Tac Toe, and I'm going to click the box to add the public static void main method there. We're not using Java 21 preview features yet, so we can't just say void main, but we will be doing that in the very near future. And yes, I'm using Eclipse. You can use any IDE you want here. I'm not using any tricks. And by the way, if you want to use an online compiler like Replit or One Compiler, I highly recommend it. That avoids you having to install the JDK or Java or anything like that. And yes, I am in light mode here. So I would like to apologize to all of you dark mode maniacs out there who are complaining about this. I would like to think that the damage that these photons are doing to your retinas right now as you watch this in light mode is worth continuing on with the rest of this tutorial. So please do not tune out just because of all of the lightness here. Okay, now starting off, one of the things I like to do is just declare all of my variables. One of the variables that I need is an array of charts to represent all of the different squares on the board. So I'm going to create a variable of type char array. I'm going to call it board, and I'm going to make it equal to, well, just numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. There we go. That is almost done. I gotta close off that bracket, throw in the semicolon, and boom, there we go. We are done. So that kind of sets things up for me. Now, I do like to declare all of my variables up front, and there's a couple of variables that I'm gonna need as well, along with the board. There are 9 squares And if 9 squares are selected and there's no winner, the game is a tie. So I want to keep track of the number of squares played. And if the number of squares played ever exceeds 9, then we know that the game has resulted in a draw. So I want to keep track of that. I want to keep track of whose turn it is as well. So we'll start off with X, and then after X plays, it will be Y that will play. And you know, I also want to keep track of the have a game-ending message. Basically, I just want to have a message that prints out to the user at the end of the game. If it's a draw, we'll say hard battle fought to a draw. I don't know, something like that. And then I guess the last line of code is just to print that out, system.out.println, the game ending message. Now, we may be getting a bit ahead of ourselves by writing out the last line of the code, but I just want to kind of show. And of course, it's initially set to hard battle fought to a draw, because we'll assume that most of the time it's a draw. And then as the game is played, if somebody wins, we change the game ending message to way to go, you won. And then of course that ends up getting printed out at the end of the program as well. Okay, so that sets us up nicely for the rest of the application. Our core variables are declared here. Now, the first thing that happens when the game loads is we print the screen to the user. So I'm going to actually create a method here, just a simple method. I'm going to call it print the board. It'll be private. It'll be static. That means it sticks to your clothes when it comes out of the dryer. It'll be void, like the emptiness of space, and then it'll be called print the board, and it'll take that char array from the basic program right there. So, you know, if we wanted to actually call that in our code, it would just be print the board and pass in the board, all of the numbers. As I said, those numbers will get changed to X's and O's as the game is played. But we just want to do the basic display at first. And the code for this is just formatting. So it's going to be system.out.println. And the first thing to display is board at 0. And then we've got some formatting. We'll put like a pipeline between the first number and the next one. And then we add board at 1. And then we do some formatting of a pipeline. Is that called a pipeline? What do you call it in? It's got some French name to it. What's it called in India? Just a pipeline? I don't know, board at 2, something like that. Let me know in the comments. So that prints out the, 1, 2, 3 with lines in between them. And then I'm going to do a divider, system.out.println. And what's the divider? It's going to be like a dash, a plus, a dash, a plus, and then a dash again. Okay, so that system, there we go, system.out.println. I'm going to just run this right now. See, run as a Java application. See if you can see. You can kind of see the formatting starting there. I'm going to do some copy and paste to finish this off. There's not much left here. And I just got to update this. 0, 1, 2, 3, 4, 5. You know how this story ends. 6, 7, and 8. And now we've got a nice little display for our users. When it starts up, it'll say, hey, which of these cells do you want to choose? 1, 2, 3, 4, 5, 6, 7, 8, 9. And as the game plays, those will get replaced by X's or O's. But that kicks us off. That gets us going. That gets us closer to where we want to be. Now, okay, what is the logic here? Well, we don't always want to print out the board. We only print out the board when we play the game. So, and when do we play the game? We play the game so long as 9 squares haven't been selected. So I'm going to start this off with a while loop. I'm going to say while the number of squares played is less than 9, then in that case, well, let's print out the board and then grab some input from the user, right? You print the board, you say, hey, what element on the board are you interested in selecting? And so that's pretty straightforward. That's just a little system.out.printf, because we're going to do some forwarding. So system.out.printf. And we're going to say choose a square player %s, and then comma whose turn it is. Okay, I'll explain this to you in a second. Okay, so what this printf does is it allows you to use a formatted string. So normally we would say choose a square player and then quotes and then plus whose turn it is and then plus quotes and then colon and then... Here you can actually just put %s's in your text string, and then whatever variables you put after the comma, after the text string, will get injected in there. So this will, if it's x's turn, if whose turn it is equal to x, well, choose a square player %s, we'll say choose a square player x when it runs. So that's a pretty cool feature. Printf's a good one to have. Now we're asking them for input, and we're going to use a scanner object to grab input from the user. So var scanner java.util.scanner system.in is how we grab that. Now, a couple of things here. I'm using var for scanner. That again, I just like inferred variable declaration inside of our methods. It's way easier to use. Also, if I didn't use var there, I'd have to say the whole variable type, which would have been java.util.scanner, which would get verbose. And also I could have imported java.util.star or import java.util.scanner and not have to put java.util there. That's completely valid. In these tutorials, sometimes people just move into a certain spot or something like that, and they may not see the import up top, so they'll type it in without the import and get an error. So, it's a little bit more explicit, and I think better for a tutorial like this. But the scanner can be used to grab input from the user. It can actually take text input if it's numeric and turn it into an int data type. So I could say var input equals scanner.nextInt, and assuming that the user has actually typed in numeric input, it'll actually take that text and turn it into an int for me. So that's super convenient. It saves some having to massage the input into an int, do a convert from a string to an int in my code. Of course, if somebody types in something that's not an int, I'll get a number format exception. So we've got some error handling to do in the future, it seems. But for now, if we've got the input from the user says, I want square number 5, we know that that maps to element 4 in our char array called board, because the array uses zero-based counting. So we can say board at input -1 is equal to, we want to update that element in the board array to X or O, depending on whose turn it is. So board at input -1 equals whose turn it is, because that variable holds either the letter X or O, depending on whose turn it is. Now, we've got that input from the user. When we get input from the user, when a user has selected an element on the board, the thing that we have to do next is we have to figure out if the user won the game. Right now, in theory, we only have to do this check after 5 squares have been selected, because you can't win the game on your first square, but we'll add that as an enhancement for later on. But we do need to check to see if the game was won. And this is actually pretty complicated, because the game can be won in 8 different ways. You can get 3 in a row, you can get 3 in a column, you can get 3 diagonally those 2 ways, 3 plus 3 plus 2, that's 8 different combinations. To make matters even worse, the actual logic is fairly verbose. So in order to just check to see if a user got the first, second, and third element on the first row, you would need an if statement like this. If the board at 0 is equal to whoever's turn it is, and board at 1 is equal to whose turn it is, and board at 2 is equal to whose turn it is, well, that means that, well, the game has been won. So I guess, I don't know, what would we do if the game was won? We would say the game ending message equals congratulations, 1. I guess we break out of the loop or something like that. But yeah, if they get a row, if they get the first row, well, the game is 1. And then we break out of the loop because we don't do anything anymore. But that's just the first row. We've also got to check 4, 5, 6, 7, 8, 9, 1, 4, 7, 2, 5, 8, 3, 6, 9, 1, 5, 9, and 7, 5, 3, right? Like, it gets pretty crazy there to check all of those elements. And actually, I said the squares, it should be zero-based counting. So anyways, it gets ugly. And in fact, if I was to try and put this all on one line, I don't even think it would fit, right? Like, there we go. Yeah, it's like, it's nasty. Now, I'm actually going to tell you a secret right now. I got a way to make this a bit more compact. It's still going to be a mess. It's still going to be a dog's breakfast, but I can make it compact. And I'm going to use a little trick. And the trick is this. The char data type in Java is actually an integer type. You always think of it as a character, as a letter, but it's actually a number that points to a Unicode value. But it is a number. It just is mapped to a Unicode value that is a letter. But you can add chars in Java, you can subtract chars in Java, and you can multiply chars in Java. And we're trying to see if all of the elements in a column or all the elements in a given row are the same letter. And so we can actually check to see if, you know, each element in the row added to each other, so element at 1, element 2, element at 3, if those 3 elements added together equal 3 times the value of x or 3 times the value of O, we know that that means that the entire row is x or the entire row is O, right? We can kind of use math to figure out whether the user won the game. Let me show it to you here. So instead of this great big crazy line of code here, what I'm going to do is I'm going to say, so there's my if statement. If, let me see, board at 0 plus board at 1 plus board at 2 equals whose turn it is times 3, right? So if it's x, 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 so x plus x plus x equals x times 3, that means we won the game, right? And so that is the trick there to see if the user won. Now, that's only the first board. We've actually got to do all of the other ones as well. So give me 1 second and let me just finish this off. Okay, I think I've got all 8 combinations there, and that looks good. As I said, it's a dog's breakfast. It's not elegant by any means, but we got 8 combinations we've got to figure out, so we've got to check all of them. As you can see, if the game is won, we change the congratulations message, and then at the end of the loop, after we break out of it, we print that message out. And of course, there is an else statement here, right? If the user didn't win, well, the number of squares played has to increase by 1, right? We need to increase the number of squares played. And after we've increased the number of squares played, let me see, there's a variable correct up here. Number of squares played. Here we go. Yeah, you gotta, it's one of the things I hate about Java. You gotta name all of your variables consistently. Maybe they'll fix that in a future version. Okay, the number of squares played plus plus increases, and then we have to figure out whose turn it is, right? So if X just played, well, we need to change it to Y. If O just played, we need to change it to X. So we need some sort of conditional logic like this. If whose turn it is X, so if X just played, then whose turn it is becomes O. I keep thinking Y. Otherwise, if it wasn't X's turn, if it was O's turn, then whose turn it is should become X. And look at that. First year Java program mistake error there. Forgot the semicolon, used a double equals. Assignment is a single equal sign, right? Whose turn it is becomes 0. Conditional check, if whose turn it is quote X, is X. That's a double equal sign. So double equal sign comparison, single equal sign assignment there. But wow, look at this code. If the user won, then change the game ending message to congratulations, you won. If they didn't win, increase the number of squares played and then switch from player X to player O or from player O to player X. We do know that if the number of squares played exceeds the number of number 9, so if more than 9 squares have been played, then we exit the game and we print out the game ending message. And of course the game ending message, if it's not been changed to congratulations you won, is hard fought battle, draw fought to a draw. I'm going to scroll up to the top here so you can see all of the class right from the start. Go down to the if statement there. Tidy this up down here, show a little bit of the printout of the board. And there you go, that's the whole class. And I'm going to give this a try. So let's see how our game runs. So starting off, what do you want to choose? X will choose 1, Y will choose 2, X will choose 3. I said Y, I meant O. O will choose 4. X will choose 7. O will choose 5, which allows X to choose 6. And so O will choose 9. And then X will choose 8. And it says hard battle fought to a draw. So if all of the squares are selected and there's no clear winner, then it says a draw. Okay, well, let's run this again, see if we can actually get a winner chicken dinner. And so X is 1, Y is 2, X is 3, Y is 4, X is 5. I keep saying Y, but I mean O. And then we'll go number 7 on X for the win. And boom, congratulations, you won. Now, I will say we didn't see the actual win there. So after congratulations, you win, before that, we should actually do a print, right? Print the board. So we'll print the board, and now it'll be more clear when the user wins. So I'm going to run that one more time. So I'll show you a big screen there. What I did was I said, if the user wins, we actually want to see the board printed with the win. So we print the board before we congratulate them. And now when we win, so we'll say 1, 2, 3, 4, 5, 6, 7. Congratulations, you won. And we can see now the diagonal 1, 2, 3, where the user actually got the win. X got the win. It says, congratulations, you won. So there you go. That is some of the core stuff of the rock, paper, scissors program computed. However, there is some room for improvement. I'm going to do a couple of things to clean up some of this code. So you want to see this tidied up just a little bit. Stick around because that's what I'm going to do next. Okay, the first set of refactorings that we're going to do on this application is just modularizing this dog's breakfast of code here. So for example, like right here, these 4 lines of code are all associated with getting the user to select their square. So I'm going to put that all into a separate method because there's actually a lot of stuff that I have to do with that. I have to do some error handling, make sure that the input is indeed text. I also need to make sure that the user hasn't selected an item on the board that's already been selected. So there's a lot of work that actually needs to go into that section of code. So I'm just going to refactor that into a separate method. So I'm going to right click on it, say refactor, extract method, and the method is going to be called get the user to select their square, right? Spell it correctly with the right casing, but get the user to select their square, that's the method. Eclipse will figure out that the board and whose turn it is has to be passed in as arguments. So that looks good to me. If I scroll down, you can actually see that method down here, get the user to select their square. Up in my code, you know, it looks really, really nice and slick, easy to read. And then finally, there's this code here that checks to see if the user won the game, if they won the game or not. And that's ugly. So I'm going to right click on that code and again say refactor, extract method, and I'm going to put that all into a separate method. And the separate method is going to be called they won the game. So that'll be the method. And you can see Eclipse figures it's the board and whose turn it is that needs to get passed into that particular method. Okay, so now that is refactored and put into a separate method. I'm going to just tidy up these lines there. And you can see it actually looks pretty nice. If they won the game, then print the board, set the gaming ending message to congratulations, break out of the loop. Now you can actually see the loop that they're breaking out of. Otherwise, increase the number of squares played and then switch players. So those are 2 pretty nice improvements there. You can see the they won the game method just been refactored a little lower into the code as a static method that returns a Boolean. And you can also see get the user to select their square factored out into a separate method as well. It's void, it doesn't return anything. You know, one other thing, just looking at this, that I think I could improve, down here on that else statement, right? We don't have that Java conditional operator that we talked about before. So we could actually replace this code here with one line where we say whose turn is it is actually equal to whose turn it is. It's not is it, it is equal to whose turn it is equal X. And so this says, let's set whose turn it is equal to the result of this conditional statement. If whose turn it is equal to X, then, that's the question mark, return O. Otherwise, return X. Okay, and so that's the Java ternary operator. That is a Java conditional operator. And it says, if whose turn it is equal to X, then return 0. That's after the question mark. Otherwise, return X. And that code replaces that code. Look at that for just a second. You can see that one line of code is actually implementing that if-else statement underneath. So we can really tighten this code up by using that and deleting that other code. And look at this, we can now fit that whole method onto the screen. I need to trim down one more white space and it all fits on. There we go. Pretty proud of that. And of course the other methods are just below, so you can scroll down and see those as well. But some of the bloat is being taken out of those methods and the code looks a lot more structured, a lot more modular. Okay, now that is some of the basic refactorings. The next thing that I need to do is go in and refactor this, get the user to select their square, because there's a few improvements that need to be made there. But that's what we're going to do next. Okay, the last thing to work on here is this get the user to select their square method. There's a few things that could go wrong here. And what I want to do is I want to make sure that this method keeps running until we actually get valid user input from the user. So I'm going to do something sneaky to start off. I'm actually going to wrap this in an infinite loop. So I'm going to say source, I'm going to say surround with a do while loop, and the do while loop is going to keep running so long as true is equal to true. So that creates an infinite loop. And so this particular method is going to run until a condition happens in which we can break out of this infinite loop. And that condition is getting valid input from the user. Because there's a couple of ways that we could end up with not valid input. One way that can happen is if somebody doesn't type in something numeric. If we type in something that's not numeric, we end up getting some sort of like mismatched or number format exception. So we want to be aware of the fact that this code could potentially throw an exception. So we want to surround all of that code in a try-catch block. So if they type in something incorrectly, we want to catch the exception that gets thrown and say system.out.println something went wrong. Please enter a square again. Okay, so if they type in like a letter or type in one, it's just going to keep asking them, no, try again. Please enter a square number again. So that's one way to handle the fact that that scanner.nextInt method might throw an exception on bad data. Since this is all inside of an infinite while loop, well, if they keep typing in bad data, this is going to keep looping around and asking for input. Now, at the same time, we don't have any situation where we break out of the loop. And of course, if we actually get valid input, well, we want to break out of the loop. So we'll throw that break right at the end of that block of code, because if an exception is thrown, we never get there. But if an exception isn't thrown, well, everything goes on as normal. We get the valid input. We set it to whose turn it is. We update the board. And then we can break out of that infinite loop. So essentially, if we can get down to this line of code here, get valid input, no exceptions are thrown, well, we've updated the board with the user selection. We can then break out. So that's all pretty good. Now, that handles bad data. But what happens if the user actually selects an element on the board that's already selected, right? So they should only be able to select a number, right? We'll display 1, 2, 3, 4, 5, 6, 7, 8, 9 on an open board, but eventually those numbers get replaced by X's or O's. And a user can't select a square that's already an X or an O. So we need to actually do this. This little board and break line here, I'm going to indent that in, and I'm going to check to see what the input is. And I'm going to say if character.isDigit. And so this is a method of the character class that can check to see if input is a digit. And so I'm going to check to see if the element on the board that somebody has selected is in fact a digit, because they can only select digits, right? Board elements that are numbers. If it's an X or an O, not digit, they can't select it. So if the item that they selected is actually a digit that's valid to be selected from the board, so board at input -1, see if I can get all of the brackets figured out there. Okay, I think I got everything matched. So if the item that they've selected, if the square that they've selected is currently a digit, that's valid. Okay, it means they haven't selected something that's already been selected as an X or an O. So if that's the case, well, then we can select the element in the board that they selected to whatever their letter is, X or an O, and then break out of the loop. Otherwise, we have to say to the user system.out.println, sorry, that square is taken. Then it'll say, and then we'll ask the user once again, because it'll go through that loop and there's not the break. So now we've actually really hardened our application. We've made it pretty bulletproof, right? We've got an infinite loop that will keep taking input from the user until it's valid. When it's valid, we will exit this infinite loop with a break. But if it's not valid, be it an exception being thrown, or they're trying to pick a item on the square that's already been selected, we're going to handle that. We're not going to break the program. It's not going to get corrupted. It's not going to exit with an error. We're going to handle the errors and run gracefully. Okay, so there we go. That is the code here. I think I'm going to scroll up, take a look at this code here. That all looks good to me. Time to run this application, run it as a Java application, and please choose a square X. So X will choose number 1. O will choose number 1, and it says, sorry, that square is taken. Choose a square, player O. O will say number 1 again because they are indignant. And it says, no, you can't do that. So O will choose square number 2, and square number 2 becomes an O. X will choose number 3, but type in 3, okay? And that causes an error. It says something went wrong. Please enter a square again. But it's still X's turn, right? So it's been smart enough not to go to somebody else's turn. So X will choose number 3, and then O will choose number 4, and then X will choose number 5, and number 6, and number 7. And with 7 being selected, we get a diagonal there on X, and it now says, congratulations, you have won the game. So there you go. That is a tic-tac-toe program written with a single dimension char array handling some user input and validation errors, and I think creating a pretty cool, neat little experience for the user. So, hopefully you tried this on your own. And if you didn't, I would say, maybe think of a slightly different approach, or, start from scratch and see if you can remember kind of what we did there and see if you can do it on your own, right? Just following along on these tutorials is part of learning, but getting to a higher level of learning where you've got higher levels of comprehension is kind of figuring it out and doing it on your own. So please do that. Now, if you did enjoy that tutorial, why don't you head over to TheServerSide.com. I'm the editor-in-chief over there. We got lots of great tutorials on Java, on Agile, on Scrum, on DevOps, on Git, on all sorts of programming related topics. If you're interested in my personal antics, follow me on Twitter or on X. I'm at CameronMCNZ. And you know what? I would really love to hear from you. So if you enjoyed this tutorial, tweet at me on X and share the link and let me know that you enjoyed it. I would also say that I'm doing a lot of work these days on a new programming language named Mojo. It's set to replace Python and the many problems with Python. And it's statically typed like Java. And in fact, I think the world is going to need a lot of Java programmers to teach Python programmers how to program in Java. So I've got a newsletter that talks all about what Mojo is and why we're going to need Java developers to help lead the AI and ML space in the near future. So if you want to learn more about what's going on in the industry, some of the big trends, please take a look at the link in the description and sign up for my newsletter. I would also say I got a couple of books available too on Amazon. So I wrote a book called Pickering of Springfield, all about the Simpsons and the true location of the city of Springfield and the Simpsons. Got a book called Hibernate Made Easy behind there, which I wrote. And I've also been working with a young freelancer named Darcy DeClute, who published a Scrum Master certification guide late last year. And people are using it to consistently score 100% on the Scrum Master exam. So if you're interested in Agile, if you're interested in Scrum, if you're interested in advancing your career, you know anybody who is, I recommend the Scrum Master certification guide because it really is the best that's out there. And otherwise, that's about it. Finally, I'd say, if you're watching this on YouTube, why don't you subscribe on YouTube?